and going to do get some. I'm going to look these over. I'm going to give these back then, and just we're going to do it on Friday. It just kind of makes sense to do that because then that's because when we're starting to review for the final, and it's just I'd rather do that than Wednesday. So after I just get these recorded, I'll hand those back, and then Friday. And then I'll probably give you more details on Wednesday, exactly what problems will be on there. It's not going to be a full period thing, hopefully like 15, 20 minutes. Just do a couple of the problems, make sure you've kind of made your corrections on there. So that will be Friday for that chapter. Oh, what chapter was that? 4, for chapter 4. Hey, this is the last part of chapter 10. It's called the hyperbola. Okay. We're going to define it, and this is probably the one you're least familiar with, least comfortable. You know what a circle looks like. You know what an ellipse looks like. You've dealt with parabolas for a long time. Hyperbolas, not so much. All right, here is an example of, or here's basically a hyperbola. It has two what we call branches, okay? And this isn't on your guided notes yet. In this case here, the red pieces are your branches. Your foci are on the inside of the branches, and they'll either open left and right, or they'll open up or down. Okay. And here is the way this works: is the distance for an ellipse. For an ellipse, the distance you add the distances up. It's always the same. For hyperbola, you take your two distances from any point to the two foci, and you subtract them, and it's going to be 2a. Now, I don't even have what a is yet. I'll explain that here in a second. But you're going to subtract for hyperbola. Okay, so we're going to get these two pieces of branches. Now, any piece on here, okay, any spot right here, if I take these two distances, if you take the larger distance minus the smaller distance, it's going to equal 2a. Okay, for that. All right, now this is what's on your sheet. So you see right there at the top the definition. It's a set of all points. Set of all points. The difference of whose distances from two distinct points is a constant. Okay, it is a constant. Now you see these dotted lines. I see, I might have already locked them in there. Yep. Okay, those are asymptotes. They are not actually part of the graph. The graph is the red curve. Okay, the graph is the red curve. They're technically not parabolas because parabolas don't have asymptotes. Okay, they go up at a different angle. So these will come all the way, and then they'll start going along those, and we'll show you how to get those equations. Okay, here is the distance from the center to the edge of the graph is the a value. So from here to here is a. From the center to the foci is c. I'll explain where B comes into the mix. It's not directly graphed, but B does affect the graph here. The transverse axis is the axis that goes through your center. Oops, I don't want to mess that up. It goes through the center, and it goes through your A value, your vertices, and it goes through your foci. Okay, for that. Now, a couple pieces of information here. If your transverse axis is horizontal, like you see the graph right here, it's going to look like this. Now, this has a minus. An ellipse has a plus. That is the big difference. Okay, it will have a minus. X minus h squared over a squared minus y minus k over b squared. A does not have to be the bigger number. A will go underneath a positive piece. The slope of the asymptotes, here's where the b value comes into play, is plus or minus b over a. So this is how I can figure out how to graph the asymptotes. I go up b over a. It's always rise over run. Always think of that. And rise is always attributed to the y coordinate. Okay, so the y coordinate, look underneath that would tell me b. So it's b over a. So it's always rise over run. That's kind of how I kind of keep that straight in my mind. If your center's at 0, 0, you just get x squared over a squared minus y squared over b squared equals 1. And now you got this fact here. For ellipses, it was a squared minus b squared. For hyperbolas, it is a squared plus b squared. All right, so that's just something that's easy to kind of get mixed up and confused. But for hyperbolas, it is a squared plus b squared. The constant difference, whatever your two distances are, d1 minus d2, is always equal to 2a. A is your distance from the center to the vertex. Okay, so any point on here, right there to that, so that, I'll call that d2 because it's smaller. d1 minus d2 has to equal 2a, okay, for that. Now, if your transverse axis is vertical, so basically it opens up and down. Okay, so here's the big difference here. If the x piece is positive, and we're subtracting the y piece, it opens left and right. If the y piece is positive, look, it's going to be y minus k squared over a squared. The a goes underneath the positive piece. The a is not the bigger one. So there's some subtle differences between hyperbolas and ellipses. Your center is hk. Now the slope of the asymptotes, rise over run, instead of b over a, it's going to be a over b. Now I don't try to memorize those. I just always do rise over run. So I don't try to memorize which one's a, which one's b. I mean, if that's what you need to do, that's fine. But I always go, whatever's underneath the y value is my rise. Whatever's underneath the x value is my run. Okay. And so this one will open up and down. Here's your asymptotes, goes through the center. Okay, there's your C value, there's your A value. Okay, so that's with the transverse axis, which goes through the vertices and the foci, is vertical. It's going to open up and down. Okay. All right, let's just go through and take a look at everything here. All right, you need to find the center. You need to find the foci. We need to find the vertices, and we're going to sketch its graph. Now, we also going to include the asymptotes, and I want the equations of the asymptotes, which I'll go over with you. All right, from here, first of all, if you need to look up above, that is absolutely fine. Which way does it open? Let's figure that out first. Okay, Peyton, what do you think? Okay, it opens up horizontally. It's going to open up left and right. Okay, because the x piece is the positive piece. Now, what is our center? Okay, Eddie, do you know what the center is?
Yeah, it's -1. 0.
Not -1, 0.
Oh, 1, 0.
1, 0. That's all right. Our center is 1, 0. All right, which one's the A? Which one's the B? Which one's the A? Which one's the B? And like I said, you might need to keep looking up above until you get a little more comfortable. Bria, which one's the A or A squared, and which one's the B squared? 9 squared is the A squared. I think it's the 4. The A, and this is the difference between ellipsis and hyperbola. The A is always underneath the positive piece. Okay. So the A is always underneath the positive piece, because that's going to be important on how far we go in our first case. So A squared, and this is different because for ellipses, the A was always the bigger one. Okay, not true in hyperbolas. So A squared equals 4, which means A equals 2. B squared equals 9, which means B equals 3. All right, the slope of the asymptotes. And here's what you got to watch. One of them's B over A, one of them's A over B. It's rise over run. Which one's underneath the Y value? Okay.
2.
Which one's underneath the Y value? 3.
Sorry.
That's all right. So it's going to be plus or minus 3 over 2. Okay, plus or minus 3 over 2. All right, now here's how I'm going to go about graphing this one. These. Okay, so some people do it the same way, some people change it up. Oh, made it. So our center is 1, 0. Okay, I'm going to use the slope to make a box, a rectangular box. And I'm going to go up 3 and over 2. So I'm going to go from the center, I'm going to go up 1, 2, 3 over 2. put a dot. I'm going to go up 1, 2, 3 to the left 2. I'm going to go down 1, 2, 3 to the right 2. I'm going to go down 1, 2, 3 to the left 2. And I'm going to just kind of make this rectangular. Now this isn't a have to thing, but I like to do this. Okay, those are what my asymptotes are going to go through. We are right on that one. So that's going to be kind of the guide for my asymptotes. So I'm going to use right here, and I'm going to go through those. I'm going to carry it through on both sides. And actually from each point, you can go up 3 and over 2. All right, so there's your asymptotes. Now we said it opens up left or right. Let me go back here to what this looks like. And let me get rid of, oops. There, and I still got my C value. Okay, so we need to go where A is, and then I'm eventually gonna have to graph the C. Well, A, we already know, that just tells us where that piece of the branch hits. Okay, so what is A for this problem? A is 2, right? So that means you're gonna go left and right 2 from that point. And it should always be right on that rectangle. Okay, that's another reason I draw that. All right, I got enough information here to actually graph it. It opens up left and right. It's gonna be asymptotic to those lines. So just make sure that it goes towards them. Like that. So what are my vertices? Those are your 2 vertices. Those are 3, 0, and -1, 0. So I'm going to put -1, 0, and I'm going to put 3, 0. All right, our foci. We need to figure out where those are. We got to graph those. Well, C squared equals what? C squared equals A squared plus B squared. Okay, so C squared equals A squared, which is 4, plus 9. So that means C squared equals 13. C equals square root of 13. Now, about what is that? That is square root of 13. Use your calculators. Hey, give me it's 3 point something. 3.6, I'm guessing. Yes, 3.6. So that means you're going to go left and right, 3.6, 1, 2, 3. And we're going to mark that. So those are your 2 foci. They got to be inside the branches. They got to be inside the branches. For that. Now, what are their coordinates? Well, we started at -1. You can just do -1 minus square root of 13, comma 0. And you can do -1 plus square root of 13, comma 0. So you can just do those. All right, now the only thing I'm going to ask for it, I didn't directly ask for it here, but I need to. What are the equations of the asymptotes? Okay, what's the equations of the asymptotes? And I am going to put it in you can put it in what's called point slope form, which is y minus y1 equals m times x minus x1. Well, I know the slope. And since I know the slope for one of them is 3/2, for the other one is -3/2. And I need to know a point they go through. Well, what point do both of those lines go through? Okay. They both go through the center. What's the coordinates of the center?
0.
It is what?
1.
1, 0. So the coordinates of the center are 1, 0. So they both go through 1, 0. So I plug in 0 for y1, so it's y minus 0. M, you can go ahead and put in plus or minus 3/2 and x minus 1. Whoops, that should be 3/2, not 3/3. Yes, y minus 0 will simplify to y. You can leave it like this. That's absolutely fine. Okay, so basically that is really two answers. I don't ever expect you to rewrite it, but one of the answers would be y equals 3/2 parentheses x minus 1, and then the other one would be y equals negative 3/2 parentheses x minus 1. So those are your two equations, but you can just leave this one. All right, the biggest thing about hyperbolas, it tends to be, is like you kind of get mixed up between ellipses and then hyperbolas. You just got to be real careful first time through. Max?
For the guy, why did you subtract and add square root of 13 from -1? Like why -1?
Because why -1? Because it should have been +1, shouldn't it have? Because I have my center. Oh, maybe I was looking. No excuses. Screwed up. You started at 1. Started at 1.
Okay.
So 1 minus square root of 13, 1 plus square root of 13. Okay. All right, so we good there? The black piece is the actual hyperbola. Everything else just helps us gather, put it down. All right, flip it over. All right, we got to do the same thing. The same thing. So you got y plus 3 quantity squared over 25 minus x minus 1 squared over 4 equals 1. All right, just take a look. Flip over to the front if you need to. Think what you know, what we can figure out, what we still need to figure out from here. Identify which way does it open? Do you know the center? All right. Abby, do you know which way it opens? And what tells us? How about I do look at that? What's that?
Vertical.
Opens up vertical, and how do you know that?
Because the A is under the Y.
Well, the A is always underneath. It's what's ever positive. The Y is the positive piece. If we're subtracting the X, and it opens up and down. Because A isn't necessarily the bigger one. So, but it does open up and down. It is vertical. Okay, so we know that. And so now our center. Now watch, just be careful here. Don't just go left to right and say -3, 1. Make sure the X is your first coordinate. So the X is going to be 1. The Y is going to be -3. So I got a center of 1, -3. Okay, for that. All right, Gavin, how about my A squared and my B squared? Which one's which? What do you think?
A squared would be 25.
A squared is always underneath the positive piece. Yes, A squared is 25, so that means B squared is 4. So that means my A is 5. That means my B is 2. All right, slope. Plus or minus what? Plus or minus what? All right, be careful here. Eddie?
5/2.
5/2 is rise over run. The rise is always associated with the y coordinate. So it's plus or minus 5/2. I'm going to use that to make a box, a rectangle from the center. I'm going to go up 1, 2, 3, 4, 5, over 2 to the right, over 2 to the left, over 2 to the right, over 2 to the left. Some people don't draw in the dotted lines for the box. I mean, you don't have to. You need those 4 points though to go through those, and then draw your asymptotes through there. You might hit right. You hit right at the bottom of your graph. Oh, you hit right at the bottom of your graph. And so you'll have to extend through there. All right, so I'm gonna draw my asymptotes. Okay, so we say it opens up vertical. I know A is 5, so that means you go from the center 1, 2, 3, 4, 5, and you put a dot, and we go down 1, 2, 3, 4, 5, and we put a dot. And then I know at this point what this graph looks like. I don't have everything. I haven't finished answering the questions, but I can at least graph it. It's going to be asymptotic to those lines. Okay, so it's just going to follow right down those lines. Okay, for that. And now, so that means my vertices are those 2 points, which are 1, +2, and then 1, -8. And now to get the foci, c squared equals a squared plus b squared. C squared equals 25 plus 4. C squared equals 29. C equals square root of 29. So that's going to be a little bit more than 5. So I'm just going to mark those there. And then, so the foci will be, now I want to start at the center, which is 1, what did we say, -3. And so it's going to be, 1, -3 minus square root of 29. And then 1, -3 plus square root of 29. All right, take a second and think about the equation of the asymptotes. Yeah, that's probably, we haven't done that in a while, so that you're not quite as familiar with that. But think about what the equation of the asymptotes are. And we get y minus y1 equals m times x minus x1. We know the slope is plus or minus 5 halves, and it goes through the point 1, -3. They both hit that point, okay, the center. Okay. So now we just substitute in, and we just make it y minus -3, which is y plus 3. Just put plus or minus 5 halves, and then x minus 1. Done. That's all you need to have. Y minus -3, which is y plus 3. Plus or minus 5 halves, x minus 1. First one was horizontal ellipse, a parabola opened up left and right. Second one opened up and down. All right, now let's just take a look at this third one. Are we good? Okay, copy that one down. All right, what's the problem?
It's not standard form.
Not standard form. And it's not in nice form. So we got to put it in here. Now, you're going to have to be able to look at an equation, and just by looking at it, tell me whether it's a parabola, an ellipse, or hyperbola. Okay, now, how do we do that? A parabola only has only one term squared. So they have 2 terms squared, then it has to be an ellipse or hyperbola. Well, to be an ellipse, they both need to be positive. If one of them is negative, that means it's got to be an hyperbola. So this case has to be, because you're going to have to determine that on the test. I'm going to be told you which one it is. So now for this one here, let's put the positive part first. So you're going to group the x's. So put 9x squared minus 18x minus 4y squared minus 16y equals 43. Move the 43 over the other side. The minus 43 becomes positive 43. All right, now factor out your coefficient. So when you factor out that 9, it becomes x squared minus 2x. We're going to complete the square on the inside here. All right, be careful here. Don't get ahead of me on the second part. What's the coefficient of the y squared? It is negative 4. Factor out the negative 4. Okay, make it minus 4 on the outside. And now that means you got to divide both of those by negative 4. That becomes plus 4y. Plus, and then we're going to have a spot here. Then we need to fill in. All right, now we'll complete the square and go from there. But you want to make that a minus 4 on the outside. Don't make it a 4. Okay, because we wanted to have the standard form of a hyperbola. Now in this case here, half of negative 2 is 1. We square that, we get 1. 9 times 1 is 9. You got to make sure that's a 9 on the outside there. Okay, half of 4 is 2. And now you square it, you get 4. Okay, what do I got to put on that other side?
Negative 16.
Negative 16, because you're multiplying negative 4 times 4. So that's got to be negative 16. Now, that gives me 9 parentheses x minus 1 quantity squared minus 4 parentheses y plus 2 quantity squared. All right, what does that whole thing equal over on the other side? Hopefully, well, it equals 36, right? We hope, but it doesn't have to. Like, we hope that this 9 and this 4 will divide into that 36, but it doesn't have to, okay? More often than not, though, we make them up so it does. Divide by 36. We're not done till we get, and I don't want any coefficient in front of the numerator. So it's x minus 1 squared. 9 over 36 reduces to 1 over 4 minus 4y plus 2 squared over 9 equals 1. All right, so now we got it where we need it. All right, think about what we know. Think about what your, which way it opens. Think about your center. Think about the slopes of the asymptotes and which one's A and B. All right, so take a second. You need to flip back over to the front, do that, and then I'll kind of continue with this here in a second. I want you to think through it first. Yeah.
Is the 4 still supposed to be up there?
No, it is not. It is not. So it should just be, and we don't want a coefficient in front of there, so thank you. Oh, all right, Maria, what's the center?
1 negative 2.
Jenna, which way does this open, left or right or up or down?
Left and right.
Good, 1, negative 2. It's going to open up left and right because the x is the piece being squared. A squared and B squared. Okay, A squared and B squared. Peyton.
I had a squared equals 4, b squared equals 9.
Good. A squared equals 4, which means A is 2. B squared equals 9, which means B is 3. All right, slope. Sarah.
Plus or minus 3 over 2.
Good. Plus or minus 3 halves. Rise over run, whatever's underneath the y. All right, so that means that's probably going to be sometimes the biggest mistake. So I'm going to go from the center up 3 over 2, up 3 over 2, down 3 over 2, down 3 over 2. I'm going to create my little rectangular box. That's going to give me my corners to draw through the asymptotes. Like I say, some people will just leave those corners. I'm going to draw in the box as well. And now I'm going to draw in the asymptotes. And since the A value, since it opens up left and right, that tells us how far to go. And that also means another reason I draw that box is because that's where my vertices will be. They'll hit right on that box. Okay, if I've drawn everything correctly. And so now I got enough information to actually sketch it. And AC squared equals A squared plus B squared, which means we're going to get that 13 again. C equals 4 plus 9. C squared equals 13. So C equals square root of 13, which we said was what, 3.6. So we go 1, 2, 3.6, 1, 2, 3.6. All right, so let's list what we have here. I think we can do everything at this point. Vertices will be -1, -2, and +3, -2. My foci are going to go from the center, which is 1, so it should be 1 minus square root of 13, -2, 1 plus square root of 13, -2. And equation of the asymptotes. Just use that typical point slope form. Y minus y1 equals m times x minus x1. Our slope we said was 3/2 plus or minus 3/2, and it goes through the point 1, -2. So in the end, I got y minus -2, which is y plus 2, plus or minus 3/2, x minus 1. Okay, so there's a lot going on with hyperbolas. Got a hand up?
Yeah, I was just gonna ask, can we leave the foci as 1 plus or minus square root?
Yeah, sometimes I'll do that. That's fine. You can do that. Okay, now if you got it in this form, you got to look which one's the minus. Make sure that's the second piece. Okay, for that. All right, we're not going to do those other two. Those are for tomorrow. So page 982. Okay, graph all of them. So there's 4 of them.